Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss another one concept regarding the jet propulsion of ships. So in our last lecture, we have discussed regarding the concept of jet propulsion and the application of jet propulsion on tanks. Now in this lecture, we'll see the jet propulsion of ships. So in the previous concept, we have seen that the jet propulsion is working under the based on the Newton's third law of motion. It is working based on the principle of Newton's third law of motion, and which says that every action is having an equal and opposite reaction. Okay, Newton's third law of motion. So here also the same concept, like the application of jet principle, we can say propulsion principle actually. So the principle of jet propulsion, which the ship is running with the help of water, or we can say the ship is driven by the help of water. Okay, how it is? So let's see here. This is the ship was taken here, and as you can see, the direction of the ship is given in this direction. That means the ship is moving in this direction. So how the ship is moving, that we are going to learn here. Okay, so in the ship we have taken two different two orifices are there at the two sides, and this is the inlet of this orifice, and through this the water is going inside to the ship. A jet of water, we can say jet of water which is discharged at the back. So you can see this is the velocity which is known as the jet of water, and the velocity of water, or the jet of water which is discharged from this ship, that is the back of the ship. Okay, and that is also called a stern. That is also called as stern. So the jet of water which is discharged from the back of the ship, okay, which exerts a propulsive force on the ship. Okay, which exerts a propulsive force. That means the jet of water exerts a propulsive force on the ship. How it is how it is reacting? So it's based on the concept of, like, you can say, suppose when the body is moving in this direction, so obviously there is an opposite reaction will be there. So this velocity of water, or the jet of water gives a reaction force to the ship. That's why the ship started moving in this direction. So here the jet of water is coming in out of this ship in this direction. Simultaneously, the direction of ship is moving opposite to this one. And in this ship, actually, the water is coming out, coming in through this inlet, and there is a centrifugal pump is fitted here. So how this orifice is taken water, actually, you can say. So centrifugal pump, we know that the pump will be like it is like, inside this pump, your vanes will be there, or blades are there, and this is the suction part of this, and this is the delivery part of this. You can say delivery pump, delivery pipe, and this is suction pipe. So here also similar thing is there. You can say this is the suction part is there in both of the side. The water comes in, and this is the centrifugal pump here, and this is the exist of this, or you can say the delivery pipe from the centrifugal pump. So the ship carries a centrifugal pump which takes the water from the outside, or you can say because the ship is moving in the, suppose this is the sea area. So the water taken by this pump from the sea water. This is, suppose, sea water is there. So the pump takes the water from the sea water, and the water is discharged through the orifice, you can say, or back of the ship, okay, with a velocity of v. So velocity v equal to, this is, we can write velocity of jet of water. Okay, and similarly we can write this is u equal to, this is the velocity of ship. Okay, and which moves in the opposite direction to the velocity of jet. Why? Because it gives a reaction force to the ship. That's why the ship started moving in this direction. So the water from the surrounding sea, you can see the water which is taken by the centrifugal pump from the surrounding sea, okay, that can be taken in two different ways. One is, see, this pump is taking the water from the surrounding of sea. So this process can be taken in two different ways. The first one is, you can say, when the inlet of the orifice are right angles. Now you can see this is the inlet of the water and this is the pump. So in this condition, this is the pump is there and the water is coming here like this. So water is coming here like this. That means it is perpendicular to this one. Now you can see the first case is through the inlet orifice, and when at the right angles, to the directions, right angles to the motion of the ship, or you can say to the direction of ship, right angles to direction of ship. This is one condition. And second condition is, okay, through the inlet orifice. Another condition will be like, this is the pump, suppose. Now this is the pump is there, and the direction will be like in this direction, and our orifice also will be at this position. Okay, so orifice will be also in the same position. So which direction the ship is moving, at the same direction the orifice will be there. So which are facing, you can say the orifices are facing, the orifice facing to the direction of motion of ship. So this is our second condition. So in this lecture we'll discuss the first one. The second one, this one is the second one. So this we'll discuss in our next lecture. So the first one we'll discuss here now. So first one is actually when the inlet orifice are right angles to the motion of the ship. As you can see, this is the right angle to the motion of the ship. This is the motion of the ship, and the inlet is right angle to this one. Okay. So you can see this is the, as I told you, this is the total explanation about the ship and the directions and about the pumps and how it revert backs or exerts a force on the ship as per the Newton's third law of motion. So now our duty, we need to find out what is the force exerted, actually what is the propulsive force exerted by on the ship. Okay, we need to find out what is the propulsive force. So before that, we need to consider few terminology like what already written, velocity of the jet and u. Now as we can see, the jet of velocity also coming out from this ship. That means the fluid is coming out with having some motion, as well as the ship also having a motion. So in this condition, we need to consider the relative velocity. So here, because we have seen relative velocity, when we will consider, now when two bodies are moving in same direction or opposite direction, so this relative velocity of jet with respect to, we need to consider with respect to ship. Already I told number of times regarding the relative velocity. Suppose this is a object and this is another one object, and this object is moving with a velocity of VA, and this is another object which is moving with velocity of VB. This may be 40 or 40 meter per second, and this may be 10 meter per second. So if you want to calculate the relative velocity of what? The relative velocity of VA. So with respect to VB, we need to write. So in that condition, we can write 40 minus 10, that is nothing but 30 meter per second. So we can say the relative velocity of VA with respect to VB. So when you compare these two object velocity, then only you can say relative velocity. So why we have taken the relative velocity here? Because the ship also moving and the jet of water also movement is there. There is a motion in the jet of water. So both are moving, both are in the moving conditions. Though it is moving in different directions, you can see, though both are moving in the different direction. So we need to consider that. So in this condition, we need to find out relative velocity of the jet with respect to ship. So as I told you, here it is minus. Now you can see this can be written v plus u, because v minus of u, because the minus of, in the sense this is in the reverse direction. So the direction of this motion, we can take minus of minus plus, this is v plus u, because the velocity v and u both are opposite direction, you can see. But this is v, this is u, I can write this will be equal. Okay, so this is relative velocity. Now for this, we can find out the mass of water. The mass of water, the mass of water from the orifice, from the orifice, okay, at the back of the ship, at the back of ship. That means the mass of water which is coming out from the back of the ship, we need to find out. So at this condition also we need to find out, we need to consider the relative velocity. So this one we know that the formula is rho a v, but here we need to consider rho a v r, rho a v r, which is nothing but rho a v plus u. If you want to tell me how you have identified this one, already these things also we have done previously. Okay, the mass flow rate of water. So that is mass flow rate of water is nothing but we can write mass per second, mass per time, and this one we can write mass equal to, we can write rho into volume by time second. So volume per second, this is discharge. So we can write rho into q, and rho in place of q I can write rho a v. Q is discharge, discharge equal to area into velocity. So this a equal to area of jet of water. Okay, area of jet of water, and velocity, velocity of the fluid, that one we have considered relative velocity. And in the place of relative velocity, just I kept this value v plus u. Now we need to find out the propulsive force. Now we need to find out the propulsive force exerted on the ship, exerted on the ship by the water. On the ship, we can say by the jet of water, or normally we can write like this also. So this one we can write in this way, like F equal to the propulsive force F equal to mass of water issuing per second. The mass of water issuing per second into the change in velocity, into change in velocity, because this also we have seen previously how to calculate. This is nothing but we can write F equal to mass into acceleration. So this one as per the Newton's second law of motion, and in place of again acceleration we can write mass into, we can write this acceleration equal to dv by dt. Again this is change in velocity with respect to change in time, because acceleration we can write dv by dt, and this one mass per change in time, that is mass with respect to time. So mass with respect to second, that one we already got this one, and change in velocity we can write. So change in velocity, that means what is the final velocity and what is the initial velocity. So here change in velocity we need to consider actually. So mass per second we can write this is rho a, and this is v plus u, and this change in velocity I can write this is v minus u, v minus u. So v minus u in the sense velocity of jet of water, and this is u. But here, as I told you, we need to consider the relative velocity. So I need to write Vr. So Vr value already you have seen. So you can write rho a, this is v plus u. This one already we got mass with respect to time, into vu. So vu is nothing but v plus, again we can write v plus u, and this is minus u. So you can if you write this one you can cancel it, and finally we can get this value like rho a v, and this is in bracket v plus u. So this is the force exerted on the ship. This one we can write. So this one we can give equation 2, and this one we can give equation 1. So this is about the propulsive force exerted on the ship by the jet of water. Similarly, we can find out the, once we find out the force, we can also find out the work done per second. So work done per second, we can write this is F into u, force into velocity, work done per second. Actually work done, how is to calculate? Force into distance, but work done per second we have taken, so we can write force into distance per time per second. So distance per time we can write velocity. So we can write again this one. So this is rho a, we can write v into small u, again you can multiply v plus u. So this is about the work done. Similarly, once you find out the work done, we can find out the efficiency. Okay, so efficiency of the propulsion we have already discussed in our previous lecture, like output by input, how to find out. So in that condition, we can see the previous expression what we got there. Okay, so that also easy actually. We have already identified, and the conditions also we have seen previously. So the condition actually, if you see the efficiency formula, we have seen 2 into V into U, like capital V into small u with respect to V plus U square. This is the efficiency formula we got. And what is some conditions are there, like maximum to conditions for the maximum efficiency. So when the efficiency will get maximum, now when we can see U equal to V, when U equal to V, that means this direction of the ship equal to the jet of water. When both will be equal, then we can get the maximum efficiency. So there also we found the maximum efficiency, how much we got, like 50%. So this one already we have derived in our last lecture, last video lecture, we have already discussed this one. And these things just for your information, you can go through this. And some terminologies are there, some conditions are there in this category actually. When the inlet of the orifice, you can see when it is in right angled, the direction of this is right angle of the motion of the ship. So this case actually known as, the water is drawn from the amid ship. The water is drawn from the amid ship. What is the amid ship is? Amid ship is nothing but the water is drawn at the middle of the ship. The water is drawn at the middle of the ship. That is one condition, and that concept is called is amid ship. Okay. And second one is, we can see the centrifugal pump, okay, which takes the water from the surrounding sea. Okay, so and discharge the orifice through the orifice. Here it is through orifice the water is coming in, and at this point the water is going out. So the kinetic energy of the jet, you can say the kinetic energy of the issuing jet will be, how we can write this is, like we can write this is half mv square. So in this place half mv square we can write. Again this mass is there, means like we need to consider this is half, in place of mass we can write this is rho a vr. So again vr means v plus u. Again v square is there. Again here also we need to write the v in the sense v plus u square. So we can write this is half rho a v plus u q. So this is the concept actually to find to take the kinetic energy of the jet. So this energy actually is provided by the centrifugal pump, and that is nothing but the work done by the pump to provide this energy. Okay, this is the another condition. So this is one condition, this is another one condition. So I hope you understand this theory of jet propulsion of ships. This is first condition, as I told you. This is one condition. Another condition is we'll discuss in our next lecture. The second condition is the orifice phase will be in the direction of C. So both are in the same direction. It should be there. Still, if you are having any kind of doubt, confusion in this, you can give a comment on the comment box. Thank you all.